start recording. So what we're going to be doing today is just we're going to be starting on like kind of project 3 from scratch. Not necessarily. We're going to do something similar to project 3. Um, that you can very much sort of copy the thinking processes around that. I very much intend for this to be a video you could come back to a bunch of times if you're confused on how to get going with Project 3. And so this might become like multiple sessions. I'm not really sure what to expect with this. I haven't done like a prep work for this because this is like a live coding session, and no, I don't know if authentic's the word, but like just to see like what sort of like questions am I asking as I go through trying to build something like this. So I've actually already built this exact project before. I for a for Haskell job interview that I did a while ago, I built this project called Obelisk Scrappy. Feel free to check it out on my GitHub. It's also a great example of how to build something very simple with Obelisk. Um, but all it did is effectively use the Obelisk framework to connect to my backend, where I scraped Google based on a search query. So if you typed in into the search input, um, dog, it will find you the first image of a dog on Google Images pertaining to that search. So yeah, let's do that. So starting with, I need to share my screen. That's the first. Might be important. I can just tell you guys what I'm seeing, you know. So let me go cd code. Oh, right. And I am just going to start a new project using Obelisk. So I already have Obelisk installed, which I can test by just typing in ob to see if it's a recognized command. I'm going to make directory ob scrap or ob scrappy cd, and then the first thing I want to do is use the first Obelisk command, which is ob init. So I can see it in my help menu here that printed out. What does ob init do? It does all it does a lot of heavy lifting for us. So it creates a project skeleton with like almost like an example project into itself. There's not anything like super interesting you can see by interacting with the project. Actually, that's not true. You can. So let's try this out. Let's do this. And the next thing I'm going to do, Obelisk also provides another awesome thing, which is our own version of Hoogle. So, you guys, in case you don't remember, we have Hoogle where we can search for almost any function name or any sort of type. So, like if I want something that takes like a text and turns it into an integer, for example, the length function, I can look it up like that. So Obelisk allows us to build our own version of Hoogle. Actually, I don't know. I'll not do verbose this time. But this is going to open up a Hoogle server that I can access at localhost 8080. It's going to download whatever I need, and yeah. So let's go check this out. Okay, cool. Hoogle's loaded. And then what about at localhost 8000? So we'll see we have like a minimal Obelisk example, and it just shows us like the very basics of like all that you can do with Obelisk. Sorry, Kyle, do you mind muting?
Oh, oops.
All good. And yeah, so I forget. I haven't seen this page in a while, but let's get started. So Emacs. What do I call it? Ob Scrappy. And the most interesting part of Obelisk, I'll say, is the front end. So, you know, if you are successful with projects 1 and 2, my guess is that like the backend will be easy to approach. But and I will give some more context to why that is. But the front end is where the kind of some advanced Haskell starts to creep in. And what we see here is front end is a type with a front end head and a front end body. And this right now is just a one-page application. We could, in theory, use functions to make this a multi-page application. You know, and we would do this in the front end body. And potentially the front end head if we want to make that varied based on the route that's passed in. But ultimately, you know, we're not going to be thinking about that too much today. Now, as we could I'll just go through each piece is what I'll do. So this right here is very simple. All this compiles down to, or all this results in, is a h1 welcome to Obelisk. Right, so hopefully you guys are familiar with HTML, but if you're not, you know, in general for HTML, we have some sort of like descriptor here and a tag. We can have some attributes like ID equals heading, and I wonder if they have an example of that already. Oh, I guess they don't. Oh, no, they do. So the most generic way of writing HTML in Obelisk is through the ladder function. So ladder allows us to do, you know, allows us to build any form of HTML. This L function doesn't take any arguments for the attributes that will be in the HTML resulting. Right, and we can always, you know, go and check this. You can say inspect, look at the elements. In case you're not familiar with web development, you can always go through and just look at the basic HTML. And all the normal rules of web development still like apply. So in this case, this is going to become a script with the type being application / JavaScript, and then source equals well, that's going to be something else, but like some sort of precursor, and then lib.js. The precursor, or the prefix here, sorry, is going to be a result of this function here that you see. And that's just another function that's provided by Obelisk to make web development easier. And we'll hopefully get into that. Actually, we hopefully will get into that. And then same here. You can kind of like imagine that the same thing applies for the rest of this. And of course, just in case you're not super familiar with you know, with web development, the most common thing you're going to be doing is using a class, or you know, the most common thing you're going to be doing is probably making a div with a class using Tailwind, you know, Tailwind URL, and maybe not together, but you also probably want to use style to add some CSS. And so you can do this inline like, I don't know, color is blue, because blue is my favorite color. But also too, we have this main.css. So like, if we want to do that, again, the same common rules apply to web development. There's nothing different about how we're gonna write CSS. We can see that paragraph color tags are red, and that's just normal CSS. We're not gonna go over CSS today, but that's probably the result for this here. This is paragraph tag. This is a paragraph tag. Yeah. And that's that. That's all the basic stuff I would say. And like you'll see that we have this text function, and you'll understand why we want a text function instead of just like passing, for example, like the text as another argument to the L function. The reason is that, well, ultimately, in the simplest example or simplest cases, that we can use monads to build out our HTML. So if we have a p tag here, we can have a div tag inside of it, and we'll see that we can do this through Haskell. We can like kind of reason about the type signatures here. So we have L here, kind of like just the simplest way to build like an element here. If you're not familiar with this, don't worry about that. That's not super important. Actually, you know what? Genuinely, for the most part, if you come across a function like this that uses for all, you actually can genuinely just ignore it. It means the same thing to the user of the function. If anything, it just makes your usage of the function a bit easier. But I'll save that explanation for a later date. And so anyways, we see that we have this MA argument, right? So all that is just allowing us to do inner HTML. We have this DOM builder constraint. DOM builder just simply means that we have the functionality to do stuff like add a text node, add a comment node, add an element, and place raw element, select element, whatever kind of element. Sorry, I don't know who that was, but would you be able to mute her? So yeah, and you can see again that just simply builds out the HTML of div hello world. And so text is just one example that fits into this, right? So if we look at now that, by the way, a factor of using Haskell is now that we're on the page, we can just type S, and we can search through the package. So I want to look for the text function. Oh wow, it's quite. Oh, there we are. Okay, and I can just see that it fits that type. So this function itself takes a text as input, and then it's just going to give me something of the type MA. In this case, an M unit. So unit always meaning really nothing. so last kind of thing to note, that if in case you're not familiar with monads, which is probably true, is that let's say I was to say pure hello. If I was to unwrap the variable from this, I would see that it's the same value from here. And why is that? Is because the ldiv function is just going to return back whatever it ended off on. So here, the type of ldiv, is going to result in an M text, which is going to be passed back to this, which is also going to be then an M text. And then same here. So and we can see that by doing that. I'm going to open up a shell. And just do ob run to run my project. And you can see that there's many other things that we could do in that case. We'll get into Dyntext later on. But you know what? This is a good time to take a sip of my coffee. So, any questions so far? I will admit there is already a fair bit we have covered. So if you're like feeling confused, that's totally fair. But okay.
I guess one question maybe for the chat. Has anyone here never built a website before? It's maybe a good, so we know where people are at in terms of, like if we're talking about HTML, CSS, like do you know what those are? Like, because we can definitely go into more explanation on some of this stuff. Really what we're doing is we're using Haskell as like a type safe generator for websites. So it's like you could write the website yourself or you could use Haskell.
Right, and you can even see that, like, if we go into the web inspector, we can type in whatever, you know, we can edit this HTML as it is.
So what are you doing right here, Galen? Because like you've mentioned the word DOM before.
Mm,
What is the DOM for those who might not be
yes.
aware?
So typically, yeah. So like, DOM stands for Document Object Model, and while I probably don't know the actual definition. Like the key idea is that we have HTML, um, where each sort of element is like an object that we can refer to, and perform logic based on the state of. So, for example, if we added in some JavaScript here, like we could for example say document. So we could then the word document is a global reference to the HTML as a whole, and we have some functions that we can do, like get element by ID, and we could search for an element in our HTML which has the type of ID. So like for example, if I said edit this as HTML, ID equals my ID. Now in the console, I should be able to look for my ID, and it'll say that it'll give me back that element. So you know, oh, what the heck? Oh, come on. Did I just? Oh, because I'm running in two places. That's not helpful. Have signature, right? Actually, you know what? I'm gonna add that in just so I can be a little bit more explanatory. Pardon me for 1 second. Oh, because I didn't finish that. Okay, that should work again. Okay, so now if I go back to body, I'm gonna, you know what? I'll get the just do with the image tag this time. Edit HTML ID equals my image, go back to the console, say document dot get element by ID, my image. I can then also put this as a variable, and I can do some logic based on this. So it's just become, this HTML has become an object where I can do some sort of work on it. So like if I want to get what's it, the size, scroll height, I can see how large the image is. I believe. So does anyone have any questions there so far? It's important to just understand the basics of HTML and CSS. Um,
Yeah, basically the way that I would like perfect explanation. Only thing I would add is like your browser is basically just another program, right? So like nothing magic is happening here. Your browser just like when people create a browser, all they're really doing is they're creating a view on top of an HTTP request, right? So you might have seen HTTP requests if you work on the back end. Um, Literally all this is doing is it's going to receive HTML as a string. So it receives your HTML file, your CSS file, your JavaScript file, and it's able to interpret like how to display that on the browser. So that's what the browser's responsible for. And the document object model allows us to edit that in real time. And the reason why the document object model is important is because when we're like you can create static applications, but when we go to actually create interactive applications, we're going to be interacting with that document object model to, for example, change what shows up on the screen, um, you know, do a button click, these kinds of things. So basically, the way it works, up in that little bar there where we typed localhost 8000, that's just doing an HTTP request to our server, which is running um, that server front end server that Galen started up. And then once it receives the HTML that we provide it, it displays it here, and then it's giving us a reference to that document object model. And that's where you saw that DOM builder space that in the type constraints for Reflex. That's where that comes in.
and yeah, so like, it's honestly been a while. Forgive me for this. But one of the most common things you would do in JavaScript is like add like event listeners. So now I've added an event listener to say click. Obviously, there's simpler ways to do this that you've probably seen. Um, but I'm trying to do it in the most general way possible that we could just switch out click to be something else. And now if I click on this image, I've changed the behavior through JavaScript, so that now when I click on this image, it will console.log hello or run whatever code I have here. Um, and so that's that. And so like Obelisk, and more specifically Reflex, like Reflex is the core of Obelisk. Obelisk is just simply taking Reflex and making it full stack. So I use the two like interchangeably. Um, but more often than not, I probably more specifically mean Reflex if we're talking like front end. Um, so like I think that's just important to know if you're looking for like docs and that sort of thing. Because there are docs like there's like Reflex FRP .com, I think it is, or .org. Is this it? Yeah. So like there's some tutorials here, like more resources. There's also examples that are somewhere. Yeah, Reflex examples that you can see and get familiar with, and a lot of the times actually, so they're using Obelisk here to host the Reflex examples. Um, because otherwise it would just be creating a front end and no way to serve such a front end. Um, so yeah, that's that. And so we've taken out this hello argument here. Um, Now here's like the actual kind of like interesting part, or not like if you're familiar with web development, nothing that we talked about so far should be surprising, um, and the next part is kind of like where things get like complicated, and complicated in a way that you also need to understand what's going on. Um, I don't know if I'll use this. Oh, interesting. Okay. You know what? I'm not even going to use that example. I'm just going to make my own. So we have this function pre-render that allows us to ultimately do stuff on the client. So, how should I go about this? So the first thing we're going to do, we're just going to keep it very simple. We are just going to console.log. We're just going to console.log hello. So I believe the simplest way to do this is, and I don't use this function all that often. How does eval even work? Eval. Okay. So I could say console.log hello. Will this work? We'll see. I gotta add it to the imports. Okay, I don't know what's happening there. We're just gonna stick to more familiar things here. So JSG console. I'll explain this all in a second here. Something I'm doing weird here. Okay. Maybe I will use that. Oh no, I'm silly. No, it's because I need this. Okay, there we go. So I just needed this lift JSM, and we'll get to that in a second. For this is well, the first thing I'll say is you'll probably notice this is a lot more complex than in JavaScript just saying console.log. But the complexity that is required to do something very basic like this does pay off when we get into a real application. So for context, like ACE is entirely built in Obelisk and associated libraries, and there is like a ton of front end logic that we need to do. And if we were to be doing it in JavaScript, we would have bugs like left, right, and center. Especially since there's only like really, I mean, Kyle helps sometimes, but he's more focused on teaching. You know, for the last little bit, like it's just been myself coding ACE. So like with one person coding in a non-typed language, we would see a lot more bugs and crap happening. But thankfully, with taking on this little bit of added complexity in order to have a type-safe language and type-safe program, I'm able to be a lot more productive as a whole with a real application. So just bear with me on seeing this complexity here. and this is just complaining that it does not know what the types of these are, and that's because the types of these can be any number of things. So I'm just gonna make these a string. I'm gonna add this little helper function here, which is just gonna be ID. All this is gonna do ultimately is annotate the type. I could literally do what they do down here, which is just like say this is text, but I'm lazy and I would like to write less. So I'm gonna do that. And voila, we are running. This is working. We got some warnings that we're not going to care about today. Normally, I would go crazy over them. You can see console.log. Hello. Is that for sure the same thing we're talking about? Let's make sure. We change it and we see hello world. And they're also ultimately doing the same thing here, just with a preloaded library, which is something you can also do. You can also write your own JavaScript in the static folder, which we will show, but like that's not very much a priority, as I don't even really recommend it unless you need to, and you never do need to. So yeah, let's get into this. So what's going on here? What is pre-render? So pre-render is taking two arguments. We go back to our Google. We see pre-render is, let me just blow that up here. Pre-render takes two arguments and gives us back nothing. We also have another variant, which this is based on, which is just pre-render without the underscore at the end. So what this says is we need some sort of monadic action, you could call it, or MA, and a client MA, and that's going to give us back a monadic action, or a monad wrapped dynamic TA. So there's a lot going on here, but ultimately, ultimately, what this is saying is render the first widget on the server, and then the second on the client. And this is less important here, but and we'll get into that. But ultimately, like this is just going to be run on the client, or sorry, on the server. So I can make this like, pardon me, I can make this whatever. I could say, pure 20, but then this means that I need to return an integer here as well. So I'll say pure 30. And I'm going to want to change that. And we can see that worked. And just to prove to you guys that this would fail, otherwise, it's going to say, it's going to have some issues with trying to figure out what type you've given it here. So you can see that it's expecting a num, something of the num type class, based on this argument here, and we're giving it a unit. So it's like that does not make sense. It'll be a little bit more clear if I said that this is specifically an int, and it will say that's not the correct type. It'll be a little bit more complex than that. And we'll see some of the internals around Obelisk and how it's what that magical M is. But we don't need to really think about that. And I still don't even, the thing is, when I write an application using Reflex, I still don't even always know what actually my type of M is. And the reason for that is that Reflex has a ton of these classes, like pre-render, which does look a little bit complex. And sorry, I'm noticing I'm saying like a billion times over. And that's because I'm really deeply thinking this all through. But what this is allowing us to do is not be constrained to our particular M. So M in like your normal Haskell application is just IO. And here, like IO is definitely a part of whatever M is, um, but but this allows us to work without caring about how how Obelisk is dealing with our monads. So, and the reason for that is that each monad that's provided is giving us functionality. So, like this pre-render, this is the common case I see with Reflex, is that there's a pre-render class, and then there's a pre-render T. In this case, that's not true. The closest one would be like something like hydratable, and
What do you mean by pre-render T? Because I see pre-render T here. Do you mean the
the
monad transformer for pre-render?
pardon me, yeah, I mean like pre-render big T, which is like a common thing you'll see for like monad transformers, um, and for example, hydratable T is a monad transformer. The T at the end is just like a what's the naming convention for a monad transformer. I don't mean here. I don't that's there's what I'm trying to say is that in this case, pre-render is a bit of a an odd case because there's not like an associated pre-render T, like big T, um, and that's because it's a little bit more complex than that. This is probably like one of the more complex classes that you can use um, for Obelisk, and the reason for that is because of server-sided rendering. So, for example, I don't know if we would. Let me see. Let's try and do. Oh wait. Let's try and show this. So ultimately, and I'll just get rid of this for now because it's not relevant at this moment. Um, is that this should work? Yeah, okay. This should type check. Let me type check. We'll see that this page will have somewhere um, server client. Yeah, we see it. Perfect. So we see the first version it sends is with the text server, and then it is going to update that area with using the pre-render function to update it to whatever is in this do statement here. So the reason for that is like if let's say you have like a very complex application that might take like 5 seconds to build. That's a little bit crazy. Hopefully it doesn't take 5 seconds, but we want to be as fast as possible with our web applications. So we want to send the first version of that page as soon as humanly possible, or as soon as machine possible, I suppose. And so we're gonna send this LDiv text server here. And so, like, what's the difference? In this example, there's no real difference. But let's say on the server, I try to do JavaScript. That doesn't make sense. There's no reason I should be doing JavaScript on the server. So any JavaScript that we're going to be building is going to be like to work on the client side of things. Um, right? Like if we're doing console.log, like let's say like we're using Node.js and you try to use console.log, um, or sorry, that's a bad example. Console.log does exist, but if you try to use like document, right, like JSG document, which just converts to like literally, pardon me, um, just document in like normal JavaScript, and you type that into your REPL, your Node.js REPL, it will say that document is not recognized. And so, document, even in a JavaScript environment, would only be recognized on the client, right? Um, and so that's why we want something like pre-render. And so pre-render is a little bit chaotic. Hopefully, like that makes sense so far. Please pipe up with any questions if you do have them. Um, but
I think I think pre-render can, like I know for me, for the longest time, for whatever reason, I didn't know what pre-render did.
yeah,
Um, it's really quite simple. Like it looks a little confusing, and when you get an error about pre-render, you're like, oh, what's happening?
right,
Literally all it is I believe it's the first element or the first argument to the function is what you want to happen on the server, and the second element or the second argument is what you want to happen on the client,
right.
right? So it's like this gets into server-sided rendering, which Galen spoke about a little bit. Basically, what that is you can actually pre-render things. That's why it's called pre-render. You can pre-render certain templates and shells on the server. So basically, when you make a request to the server and it gives you back this, welcome to Obelisk, right? We made a request to our front end server, and it returned back welcome to Obelisk as a string, right? But what if Obelisk was a variable from our database, right? Like so we have the name of the application is stored in our database or something. What pre-render would allow us to do is before actually rendering it to the screen, it'd grab it from the database and then return it as a string so that the very first time that we receive information from the web page, it has that information. So that's why it's called server-sided rendering, is it's actually handling a lot of the rendering on the server, meaning the backend server. Whereas here, like just typically, it's just we're providing a shell, and then all of the rendering happens on a refresh. So they call that hydration. Um, Something to maybe look into, like what the difference is between server-sided rendering and client-sided rendering. But that's really all pre-render is doing, is it's giving us the ability to like. Usually, you'll see this used for like shells. Like if anyone's ever used a website where when you first make a request to the website, you see like you see like a card, but there's no actual data in it. Maybe there's like a spinning wheel inside of the card waiting for it to actually hydrate. The reason they do that is so that you don't just get a blank white page while it's loading all the information from the back end. So it allows you to pre-render some kind of shell, because if your website is dependent on a bunch of data being processed and loaded in the back end, then it can take up to 5 seconds, right? Or it could take longer, but hopefully not. Typically, you want to take less than 3 seconds to hydrate, but you want the user to receive the template as quickly as possible. And so that's what pre-render's for.
Yeah. So like for example, like this the paragraph tag here is just like is getting replaced every single time, right? Like what was on the server sided render, or the first version of the web page that was received is just replaced in place with the updated more complex version. Um, so I think yeah, and so
Are you able to show that? I don't know if I saw. So when you
Let's try it
refresh,
here.
it should say server, and then it should switch to client really quickly, right?
Yeah, let me pop this up here. So I'm gonna look for it somewhere in here.
No, you can see it right up at the top
Oh,
there.
I'm just missing it.
Server and then client.
Yeah,
And you'll
roughly.
notice too that when it's server-sided rendering, it hasn't loaded in that the CSS file. Because client server is it? Oh wait, is it a p tag or no? Did you make that a p? Is server also a p tag?
Server also p tag. I think I changed it. So
Oh, okay, no, never mind, never mind.
goes from a div to a p tag. Right. So div p tag. Yeah, that's all that's happening here. And also too, like to further elaborate, we could have this inside of whatever. So we could like then indent all of this, and this is all going to be inside of our ID. Um, my elem. LC ID my elem. I guess that now it's hiding it because it renders so quickly. Dang it! Thought I could do that, but okay. I think that's good for explaining like what pre-render does.
Yeah, yeah, I
So
think we can move on.
yeah, but we're not necessarily done with pre-render, because I like there's a lot of patterns that you'll see the in the reflex. Pardon me. There's a lot of patterns you'll see in the reflex library. Um, oh, and we we should come back. Kyle, remind me at the end. We should come back to what is this dynamic that we're returning, and why is it dynamic? Um, but
Yeah,
yeah,
I was
because
gonna say like at some point we should talk about FRP. I mean, that might even be like a full lesson because it's like I think FRP is one of the most. There's very few FRP languages, and it's
we'll definitely
like
need
there's a
to.
reason that we kind of do it this way as opposed to like using React JS, right? We can get into some of the reasoning behind that, but maybe at the end or before.
Because React is awful.
Well, yeah,
uh,
but there's a reason. There's a reason why, right? Like
yeah,
that's based. It's not just a personal opinion.
yeah,
It's based in truths and like different concepts of programming. So
totally. Um, yeah, and ultimately, like in a nutshell, like why I'm like Reflex is so amazing is because it's so once you've learned how to use it, it's so hard to make a mistake. Like it just like it helps you along with your coding, um, and like kind of like it's just it's a great way to extend the type system is how I think of it, and just in the same way that the type system allows you to not do stuff like add a number and a string together. Reflex doesn't allow you um, you know to do other like it allows you to use your types in a way that forces you to think properly about user input and user
yeah,
events. That's ultimately what it is.
yeah,
Um,
it's basically it comes from reactive programming, which is basically it's a declarative way of programming your event tree. So everything's based off of a stream of input. Basically, everything is time dependent. Um, without getting too deep into it, I think it's probably a topic for later.
yeah,
But just understand that it's like it forces. like you don't specify what happens with the events, or sorry, you don't control what happens with the event flow. You just declare how things should change over time. And so because of that, you're removing all sense of like state errors to these different kinds of things that can happen in typical languages.
And I think the more understandable way is like the how things should change over time as events happen, like as like
Yeah.
because over the course of time, like we're interacting with this web page, I do certain events, and they're all happening over the course of time. Um, but yeah, I'll even say like the time is like not something you need to be aware of, like because
No, you don't need to think about it, but that is what, reactive programming
yeah,
in a nutshell is like.
yeah,
Everything is based on time and it abstracts that time away from you. Like I'm pretty sure that, correct me if I'm wrong, but that's what the T is in a lot of these cases, right?
that and so this is
Because there is
not
a
really
timeline that you can
yes,
change.
yes,
But
and it's a timeline, but it's not
yeah,
necessarily like time. It's not like the reason I want to be careful about like time is like we're not I remember like Kyle, you were talking about like an example that where it was like oh like we're gonna just delay a certain number of seconds and then we're gonna like run some function or
yeah,
whatever.
sorry, yeah,
Because
it's not like computation time, but it's like a timeline. Yeah, timeline is a way of
timeline.
thinking about it. Yeah,
Yeah. So like ultimately like the like more of like the ordering of time.
yeah,
Like this I click here, that's the first event. I click here, that's the second event. I click on this, that's the third event. Um, et cetera, et
exactly.
cetera. And so it knows that what happened in which order. But ultimately, even the other thing is that you'll find what's so beautiful about functional reactive programming is like you just don't care about what else happened. Like
Yeah,
when you're writing your code, it's like I don't need to know. I don't need to ever think about what is happening in the rest of the application, which I do not care about. Because if I did care about it, I would see that with my types. Um, because it would have some direct effect. Like for example, let's say that this is text here, which can change, and if I click here or I click here, that will change the text. That's one case where like we want to have like an annotation or a tagging of times and a event ordering, right? So if I like let's say like our I think the best way to think about it is not actually what happens, but let's say like our web page is really slow, um, and we click here, we see it's lagging, and we click here. What's going to happen in normal JavaScript, to my understanding, it's like a race condition. We don't know exactly what will happen. Whereas in this case, it would the value of Reflex Dom pre-render would be whatever we set it to be um, of the second action. So like let's say like okay, so let's think about this a little bit more clearly. If I click on this and it's going to say save Haskell here, and I click on this and it's going to say um, reflex. So one click would mean that save Haskell it shows up here. Two clicks or one click here means that reflex would show up here. We obviously want it to be we want the value to be um, based on the last click, right? Because it's just continually updating based on that. And so let's say there was like a race condition in normal JavaScript, the ordering of operations would be handled so that no matter what, if I click here then here, this is always going to end up becoming reflex. If I clicked here last. Um, anyways, so I think that's a bit of a tangent we went on there, but hopefully like a helpful tangent. You can let me know in the comments. But Anyways, I want to get into like what might really confuse you about working with Reflex. And one of the biggest things that confused me when I was starting is um, is this idea right here. So, like, if we look at a number of things, let me see here. That's a good other example. Um, let's do. Okay, so actually, this is another great example here. Um, Dom builder. So, our two classes our two classes of monad or context, if you will, that we've come across so far are pre-render and DOM builder. So DOM builder, like we saw before very briefly, is allowing us to make elements, right? This is like the heavy lifter of how to make elements, or how to write HTML ultimately. Pre-render is the heavy lifter of how to write JavaScript. Um, and what we'll notice is that both of them have this associated type. So a DOM builder space. And the reason, and we actually saw this with client, right? We saw that pre-render takes this client MA. So what does that like mean? Like, what is a client MA? What we're getting into here, and it's not. This is like a bit of a frustration on my part with like on Haskell, but it's not super clear that this is a type family. Um, and so type family is like our they are getting into complex advanced Haskell, so to speak, but I think they're actually quite simple if you just have a clear explanation of them. Like, all they are is a type level function. So for example, let's say I have a type family, type family, my family, where my family integer equals string. So what have I done here? I'm not totally sure I have the syntax correctly. But ultimately the idea I do have correct here. I will say all my family is a function. So this is saying if we see like if we come across this this function, my function, and it takes the type of my family A, and then I don't know, does like IO. This is going to this is like a type level function, in that this is going to be replaced. So let's say my family int is here. This is the exact same thing as writing string. And so like the question that I had when I learned about type families is like why wouldn't I just write string? Why would I just write string here instead of like my family int? And the reason for that is because you're never going to say my family int. You're going to say more likely my family A, which just means that, I guess, I forgot the syntax here, but I think they have the argument here. So this type family takes one type as an argument. I should add that. But all this is saying is like it's an overloaded way of thinking about types. So and I've never used a type family like this. That's why I'm like a little bit like unfamiliar with the syntax of it. But it makes a lot of sense when we think about something like DOM Builder. Oh, where'd that go? There we are. It makes a lot of sense when we think about something like DOM Builder, and uh, and how I was mentioning that we never really often care about what this M actually is. You know what? Like, but it must be something. This M, and so the key things that we'll see that M actually can be is um, GHCJS DOM space, hydration DOM space, and then like static DOM builder. And pardon me for 1 second here. I just gotta blow my nose. Um, just feeling quite sick today. um, but there's three core things which like we care about. You'll see there's other things that happen here. Like there's a requester. There's a hydratable T, which I guess also does matter. There's a event writer T, but like these are not super important. And how I know sorry, these instances are not super important or not worth caring about is I can see they're using some advanced Haskell, not necessarily in terms of syntax, but they're using Haskell in a beautiful way to um, to create easy generalizations so that we can not care about what this M is, that we can work without caring about what it will be. Um, so how I know that is that I see that like for example, requester T requires that TM is of the type DOM builder. So ultimately, all this means is that requester T is going to use a real instance of DOM builder here, and the heavy lifting will actually be done by something like supports hydration DOM builder T, um, supports static DOM builder T, and we have the ability. We don't have to do JavaScript. We could build just raw HTML with with Reflex. And so this is one thing we could do is use static DOM builder T. Um, but in our case, we want to use the GHC.js DOM space, and well, yeah. So we have like the point being here is like Reflex is trying to allow us to use the same high level functions without having to think so much about the inner details, right? So if you didn't understand that fully, like that's like totally fine. The key summary is that like um, it doesn't really often matter like what the M is, and so part of doing that is using this type family. So this DOM builder space M is just a way of saying um, based on this instance, what should be the monad or the context we are working with. So, and for example, um, a text node has a different DOM builder space monad, and in the context of static um, versus you know uh, with using JavaScript. Um, Kyle, am I making sense so far? Do you think, or
Yeah, I think it's like it
maybe I should
it
look
makes
this up?
sense. I think some of the other types of DOM builders, like I personally haven't seen many. I know we've used static,
Yeah,
um, but ultimately, like with all of this stuff, like you're gonna need it when you need it. Like
yeah,
you can learn every function, but
Hmm.
what if you never use half of them, right? So like the way that I like to look at this stuff is like just understand the bare minimum of what you need to know for now, and then understand how to find what you need, right? So like for like support static DOM builder, like this is just an instance for something that is a DOM builder where it has a static DOM builder inside of it, right? Um, and
And
so static DOM builder is just basically a DOM builder that can't change. It's going to render it once. This would be used for like a static web page, like a blog or something maybe.
mhm.
Um,
And I think the key
yeah.
point that I'm trying to get across is like there might be some things that you come across which look scary or confusing. Oftentimes, all that's really happening is that the library is doing a lot of heavy lifting for you. Like to build a web page that is functional reactive just takes a lot of work. Um,
One thing I'll say on that too is that like it's also because like so the reason why something like this might look confusing is because a lot happens with a very little amount of code,
yeah, yeah,
right? So like you might be used to looking at libraries in like JavaScript or in Python, um, and everything like you might be looking at like 10,000 lines of code, um, whereas like in Haskell you might be looking at 1,000 or 500, um, and so it takes a little bit to wrap your head around that. Um, Also, just the fact that in Haskell we can define our own operators. So like you'll see all these different symbols in Haskell code, and you'll be like, "What? This looks like gibberish." But all that is it's just another function.
yeah.
Like you could have like I think one of them was dot caret or something like dot the
Dot
little
carrot, yeah.
hat. Yeah. And it's just like that's just another function that someone wrote. Like they could have just called it like I forget what specifically that one does
Mhm.
or caret dot. Like this combines JavaScript tags together, right? Does it not?
Ultimately, yeah.
Yeah, like so you could have called that combine, right? But then you'd have to write combine everywhere. So it's just like people typically when they're writing libraries, they'll come up with operators that make things faster to write. And so anytime you see that, just understand that this is just a function. Someone else just wrote a function, and that to me, I think removes a lot of the confusion from Haskell. One of the things you hear online of like people who talk about, oh, I tried Haskell and it's all just a bunch of symbols and gibberish. It's like it's just a function, right? Like it's all it really is. So,
Mhm.
because literally everything in Haskell is a function. Even the types are functions, right? So,
Yeah. Um, right, and so these two things do the same thing. Um, Maybe now is a good time to jump to this and like what is going on with this. Um, and why do I not use eval? Why do I prefer to write out this piece here? Um, so um, but there's one thing I want to get to before that. Like we're looking at like this module here, and this is where a lot of the heavy lifting actually comes in. But like they even have this like sort of simplified version, or like simplified module to deal with a lot of what you want to do. So like for example, L, we can see it's going to use um, L prime, which is going to use element, which is coming from that module that we were looking at. So like it's a lot of heavy lifting done under the hood, so that all we need to do is say something like this. Um, and then we have we have the ability to interact with this in a functional reactive way, which we haven't seen yet, but we will. But with JavaScript, um, which we'll jump to now. And again, maybe like have a look through all of this, and I also encourage you to like look through this and then try to figure out like Where's button? How does button work? Like, um, oh, there we are. Look at the source code here. I'm not going to look at the source code right now because I'll get sidetracked with that. But you'll see that it's like this is like a button's a good way to learn how Reflex works and how you use it. And we'll use button in a second here. Pardon me. But we should qualify what is going on here. So we have this function JSG. I'm going to get rid of the S's for now just to simplify things because they're not doing anything really. JSG is just a way of looking up a global thing. So if I look up here, JSG, handy way to get a hold on to a reference top level JavaScript. So for example, if I could say, here we go.
Is it safe to say like could you use JSG document, for example, and get the document model?
Yeah. So like if I can say like console and document here, then I could say JSG document, right? Same thing, and yeah, that's really all there is to it. Now, JS1 is a function which we also see here. Like this set of functions like that, like if I scroll up and down a little bit, is ultimately everything you need to use with JSaddle. JS1. So we see we have a couple like variants here. JS1 through 5, just ultimately they all take a name and a certain number of arguments specified by the name of the function. So right, we see it take a name of the function and some argument to it. So we're calling the log function with the argument hello world. And now because it's JavaScript, we are in an object-oriented environment. So console is the object which has the log function. So we're gonna say something like console dot log, and console dot log. Hello. And it's gonna return as undefined. Cool. And that's ultimately all there is. Is there anything else to note here? I don't. You know what? We'll come across.
One thing I was gonna say is it's kind of like if you notice to the what's it called? If you go back to the type declaration of JS1, JS2, like you notice here the to.js file type constraint, right? So this is kind of like one of those benefits of writing your own libraries in Haskell, is that you can really control what types of values come into your functions, right? So like you can't just throw any type into JS2, right? You have to use a type that has an instance of to.js val. And in creating that instance, you need to like specify how this goes into something that JavaScript can actually understand, right? So if you were to just create, I believe if you were to just create like some kind of sum type and try to throw that in there, it would tell you that, hey, I don't know how to turn this into a JavaScript value, right? And so this really all this is doing is this is where I think we've discussed the idea of parametric polymorphism back in the a little while ago. It's the concept that like rather than specifying everything that can be, like we're constraining it from like the outside in. So a0 can be anything as long as it has an instance of to.js val. I just wanted to kind of point that out because I think it's neat.
Yeah, and we can look at examples of like what can become a JS val. And so JS val is kind of this overloaded idea, by the way, of like a JS val can really be anything. It can be anything from like the document itself to a JavaScript API to some text um, to undefined. So um, it's kind of like our like foreign interface, if you will. And we can do stuff to go to and from JS val. So you know, for example, the easiest one is to go from um, from a text. Why can't I find it? From a text to a JS val, and that's like ultimately what we're doing here is like or what it's doing for us. And I wonder, it's just yeah, like string to value. Um, it's literally just wrapping it in the wrapper, and turning it back into that. But I guess it's like parsing is the point I'm trying to get to, but I'm having trouble getting to. Is like if we parse something, coming from the JavaScript context, we're going to return that as a maybe of that value. We don't know for sure that the type converted properly. So we wrap that in a maybe to deal with that failure if it happens. Um, but to go from Haskell to JavaScript is quite easy, because um, anything that's valid, like that we can write a to.js val instance for, has a way of being represented in JavaScript. Um, so yeah, I think that's a good explanation there. Cal, do you have anything to add while I just blow my nose, or
No, no, I think if anything here is kind of seeming overkill,
yeah, totally.
like I would say just kind of bear with it for now because it, how do I say this? Other languages make hard things hard, whereas this language makes hard things easy. But sometimes that's at the cost of like verbosity or at the cost of like rather than typing console.log string, like you have to go JSG console, pipe in JS1 log, right? Like but you can just wrap that in a function too if you want, right? Like there's nothing stopping you from just having a console log function, right? So like it's, how do I say it? Yeah, that's really all I would add is like you'll really start to see, and if this is your first time working with web development, I feel like you have to almost just trust the process because like a lot of us who have worked with web have been burned by a lot of these things, and that's kind of what Reflex is solving. But if you've never seen any of those problems before, it might be hard to like imagine why things would go wrong. We'll do our best to try to explain it. Most of it comes down to just state mutation. Like any language that allows state to be mutated, especially mutated state from like in a by reference manner as opposed to by value, they're extremely prone to error and they're constantly over engineering to try to solve those errors. Whereas Haskell from the ground up is immutable and enforces purity. So like that's kind of why you get like just from the ground up, you get better, safer code is because it doesn't allow you to mutate state from different areas. And again, these issues really only become like, for example, in React, like you can create a one page application by yourself and you might never see a bug, right? But where these problems really come in is when you have a team of developers working on a massive project. Um, that's where you start to see problems because references start getting shared in places that they shouldn't be shared. state starts to change, and because you're holding on to references of state that is able to change, that's just the surface area of errors just increases exponentially as you write more code, right?
Redux. I'm thinking of
Oh my gosh,
yeah.
don't even, yeah,
The-
don't, yeah. So Redux, the use effect system in Reflex, these are common areas where like people spend months debugging things. And the alternative to that is just writing hundreds and hundreds of tests, which aren't even testing the logic of your, like they're not even testing, like we've gotten to a point where we're just writing tests to test the code, that the code that we wrote doesn't break, which we shouldn't need to do. We should just write code that can't break.
and I think specifically like what you mean by not break is like that they're type safe or that the types make sense.
Exactly, right? Like you're just writing extra, basically like a lot of these test suites are like twice the length of your actual code base. And that's being like I've seen test suites where they're like 10 to 20 times longer, more code, more complex than the actual code that you're writing. And testing is great. Like if you want to like we need to test, we will always need to test logic, right? Like you'll always need to be like, okay, if I give this the number 3, then it's going to give me 10 back. That's like just an oversimplification, right? And we're going to write those tests. Those tests are good, right? But we shouldn't need to write a test that says, well, what happens if I give it a string version of 10? Or what happens if I give it 10.0 instead of 10, right? And so it's like, yeah, Nick, exactly. You test your thinking and not the language, right? Like the language is tested just in the fact that it's using mathematics. Like the best way to put it is like why are we trying to reinvent logic? Like logic has been studied and it's been proven for thousands of years through mathematics, right? Like so
Well,
with something like JavaScript or like imperative programming in general, it's almost as if they're trying to like create like the equivalent of logic but for computing. So it's almost like rewrite, like recreate, maybe, and maybe this is just like an abstract idea, but like this is the way I think about it, is that like they're trying to rewrite the wheel, where it's like we already understand that math is pure, and math is, it's going, like if you give it 1, then it's going to give you 2, right? And if we expand that throughout the entirety of our code base, then we can, and we use that at the type level, right? So this is getting into like type and category theory. Um, then there should never be a case where something is incorrect as long as we constrain it properly, right?
right. And ultimately like what again what's meant by math is we're specifically talking like I think the closest I mean is category theory, which ultimately, like just in a nutshell, is how to deal with discrete things, right? So like, and that's everything in programming that you're doing for the most part. Unless you're doing like linear regression, you're dealing with discrete data, right? So um, for example, like a user that's not a good example. Like a user type is a discrete piece of data. We have an admin user. We have a normal user. That's a discrete piece of information. And so, like, all the logic that we're going to be doing is based around discrete data. And the biggest point here is that the best way to do that properly is to have like strong types. There's no good reason to ever have a weak type system. And like I'll see all the time like people talking on like Instagram about like why does JavaScript allow you to do this, or why does JavaScript return like 10 for this. I have like an Instagram like save folder just called JavaScript is poop, and I must have saved like a billion videos where I'm just like what the heck. And it's talked about like it's like a feature, and it's not a feature, because these things will come to bite you in the butt when something something in your logic goes wrong. The type system will break as well. Whereas if at least with Haskell, if your logic is wrong at a type level, you can get feedback on that immediately and think better about what you need to do. And so oftentimes that's like a very different structure in your thinking, and that's why Haskell is so hard to learn. Or part of why Haskell is so hard to learn is just that like it's really forcing you to actually be correct with your thinking, as opposed to just writing whatever arbitrary solution you think is correct and then saying, "Yep, this looks great," until you go and demo it and it breaks miserably. Um, which it can in theory not happen, but the
You're
only
giving
reason
me flashbacks.
yeah. The only reason that's not going to happen in JavaScript is if your types were correct and you just happen to think correctly about your types, which is also part of the reason that we're teaching you Haskell, so that you can go and work with something at a job like that uses JavaScript and know like that what it should be and think independently about that. Anyways, there's still a lot I want to get to, so I'm going to continue on. We're going to get into the simplest version of FRP. So there's a lot of research and theory on FRP or whatever. There's a lot of research and theory on a lot of Haskell stuff. Not super important for us to know up front. Let's just start with a very simple example. I want to change text. So I'm going to do something like this. Click button. And then I'm going to want I'll explain what I'm doing in a second here. And then so I have just created dynamic. What's going on here? Oh, because I didn't give it a value. Cool. So we can see this. We go back here. I've gotten rid of a bunch of stuff, and so all that. Pardon me. All that's going to happen when I click this button. When I click my button, is going to change the text to new. Cool. And it will continue changing it to new. Won't look like anything is changing, but it's continually setting the value to new. So let's prove that. I'll say click 2. And I'm going to add another button here. Two is going to give I'm just naming it value. Button 2 is going to give value 2. And now we need to start understanding like what is actually happening here. So I'll take a break from talking about this, and we'll understand how do we get this kind of back and forth between two buttons. And what we'll see is that I click button 1, it'll turn this value to new, and I click button 2, it'll turn it to value 2. What are the types that we're dealing with here? So I'm going to use typed holes here to figure out what the type is here. If you have Haskell language server, you can also do that. I prefer this because it helps me focus. I can see we have this event T. Okay, cool. So what this means is that this is a user event, right? Which I know is whenever they click the button. And so in Reflex, we have events, right? We'll have let's say an event T, and we'll have a dynamic T, and then kind of very similar to dynamic. But these are the two workhorses: the event and dynamic, as we'll see. There's also behavior, and behavior we're not going to worry about for now because if you understand dynamic, um, you'll probably easily understand behavior, and so we'll return to that at the end. Um, and we're going to see too that this click 2 is also going to be a whatever. Now there's also going to be an event, and so I want to combine these two events in a certain way, using functional reactive programming, but before I can get to that, I need to understand like what's happening here. So this is like the key stopping point, I'll say, and that's because this is a dynamic. Dynamic does like a lot of like heavy lifting for us in terms of what Kyle was talking about with mutating state. So in JavaScript, like let's say we're thinking in JavaScript, this would be just a text, but here it's a dynamic text. We have a type to specify that this text is not just a text. It's not just any text. This is a dynamic text, and so like think differently about it. And it's the same thing as like any other type. Like any type is just to inform, to make sure that we're on the same page as the compiler, right? Because like the character of one in JavaScript, for example, could be an integer. It could also be a string, or a singular character. So, but we in Haskell we want to say something like int, so that we know that this is something we want to do mathematical operations on, and that we can do mathematical operations on. Whereas if this was just a string, then we could not do mathematical operations on it. And that's important to keep our program on track and make sure we don't write crazy bugs.
Well, hold on, Galen. In JavaScript, you can do mathematical operations on a string.
Oh, is that so?
Yes.
Okay, let's try 1 plus document. Interesting. We can add
Exactly. That's
1
what I'm
plus
saying.
document. Like, can we do document plus document? I wonder. And
It just adds them to an array. It's like what?
It just gives us like I forget what this is called, the actual.
We could spend all day doing this.
Crazy. So, but we want to. What I would rather have happen. I don't want this false positive. I hate false positives more than anything. You'll learn in programming, if you don't already, that like the false positives are the biggest productivity killer by a mile. Because I'll write 1 plus document, whatever. Hopefully I don't, but let's say I write something like this, or maybe I'm writing like 1 plus x. I have some bad naming here, but I actually previously set in my application that x is equal to document, and maybe before that point it was equal to 1. So I did x plus 1, but then at some point I said x is now equal to document. I mutated it to a completely different type, and now I'm going to say x plus 1 again, and I get some crazy crap. And I'm not going to figure this out for a while. What's probably going to happen is that I'm going to try and use the result of that, and that's going to create another chained false positive, where I'm going to be looking at my web page like, what's going on? So I'd much rather that this compiler screams at me and says, "Do not do that. That's stupid." Like, what are you thinking?
Bad.
It's true. I am stupid. If I. So I am stupid. So I need this feedback immediately. Um, it's
I think
not.
the biggest thing to note there is that humans make mistakes all of the time, especially when you're working under pressure, when you're like, it will happen.
Yeah.
And this problem, like I said, gets bigger when you have more developers and more code, right? So
Yeah.
you want the compiler to tell you as much information at compile time.
Yeah. And so, pardon me. So that's why we have this wrapper of dynamic T text, is because we want that information, that this is not just some text, right? This is text, right? This argument I've given here is of the type text, um, and like I think we can even just think about it like this is not the same as this. They're like sure they're both text, but like there's a key difference, which is like this is like a like something that's being mutated by the user, right? The user has the ability to mutate the state of our application, and so we want to specifically annotate that, so that we know that you know we know the difference between the two, um, because let's say we didn't have that, like we might have some functionality, which is not aware of that, and should react quite differently, to that value. The other thing is like, everything in Haskell is immutable, which is awesome because if I say that, and technically this is actually immutable too. It will turn into mutable JavaScript. Of course, this will all compile down to mutable JavaScript. But in the context of our writing, this will be immutable. Um, right? I can't set the value. That is, I can't set the value of my text to being something else. Um, but I can use FRP to sort of model that in the runtime of JavaScript, it can change. And so and that's ultimately why we need this dynamic. And we saw this earlier with pre-render, that it also used dynamic. And what you'll see is that event and dynamic are used everywhere. They are just simply added information about some data. So, um, for example, like the same thing can happen here. I can have an event t text, um, and so that's actually what I have here. I'll look at that. I see that this is an event t text. So now, pardon me, this is um, an event carrying some text information. And so why have I done that? That's ultimately because of hold dyn. And hold dyn is your like, um, is probably the most important function in all of Reflex. Oh, I lost. Okay, there we are. And what this does, is it takes some starting value and an event, like a reference to some event, and then creates a dynamic TA. This is a simplified version of fold dyn with an F. And all this is going to do, and hopefully we'll get into fold dyn at some point, but all this is going to do is um, replace the the value contained in the dynamic, replace the dynamic value with the newest occurrence of the event. So that means that whenever this event fires, this value um, is going to be now the new value of the dynamic. So, so that's that, and we still haven't done anything with button 2 or whatever. This doesn't really do anything cool yet, but I mean, this is definitely simpler already than JavaScript, where we would have like, we want to in JavaScript we would first want to find the element which we want to click, which will be clicked. We will add an event listener, which this event listener will find the element where we want to, we want to put the text or update the text, and then we will mutate it, the element, to put text. So there's already like four things we want to do there, and we have no idea how many times we've done this, right? Like, so like, let's say like this is a massive application. We're at like 1,400 lines in this file, which is not advisable anyways. Or maybe even we've condensed it down so it's refactored, but somewhere in our code, somewhere in those refactored functions, there's two functions which deal with the same DOM area, right? Both, let's say that let's say that this area here is what is it? Do we have time for it? No, I guess we don't even. This text here is referenced by multiple different things, and we're getting into more complex logic. Like, we're not just like replacing what is there, but we're like dealing with the state of what is there. It's very easy to have bugs that are hard to think about, and they're not even necessarily like type bugs, but they're like value bugs, because it's very hard to think about that. What's awesome about FRP is that not only are we doing type safe stuff, but it's easy for us to think about our logic. So what do I mean by that? I'll add another piece of code in here, which is this, and then value 2. Click 2. And by the way, this this function just says the left hand argument is always just some value. It can be whatever, and then the right hand value is some sort of like wrapped type. So for example, event is a wrapper, and it contains some type, and so all this is going to do is replace whatever this wrapper contains. So like if this wrapper, if I did this like further and I said like new like I could say that, and I'll add. We don't need to add brackets here, but for the reader, I will do so. This will at first replace the unit that comes with button to be new, and then it will replace it to be newer. So you know what? I'm actually going to leave that there. Yeah. And so what do we do here, and why does like Reflex make it so easy to think about our logic as well? Like in a way, like what like I think it's important to give some context to like how to think about the DOM really. I mean, like in a way, like I kind of think of DOMs as being very similar to like a concurrent application, and maybe you don't know concurrency or whatever, or you're not super comfortable with it yet. But just the idea is that like there's some sort of like target, and there's many different sources. There's many sources or actors which all want to deal with that same target, right? So like the example I love to give is like let's say you have some like laundry pile. you're kind of lazy, like myself, and lazy lambda, and you have a laundry pile, and you want to program robots to deal with that laundry pile, and what's important about application logic and how you program those robots is that they need to be able to work with each other, right? So um, if like let's say like one robot is going to move the laundry pile over a couple centimeters, that little change might cause another robot to have issue with its task of grabbing red shirts and putting them into laundry. And so we have this kind of like laundry pile which many different robots or actors are dealing with, and you know they need to like they have the possibility of messing up another robot, just quite simply by their own application logic. And so like that's why like leftmost, and this idea of combining events and using hold dyn, what we're doing here is so awesome because like um, like that this is just like the best way to coordinate amongst all those different actors and all those different robots. I could add, you know, um, even like there's no more complexity for me to think about this than if I was to add like a billion more clicks, right? If I like continue to add like click 3, then I would just see that's ultimately the exact same idea. Is that I'm just going to, um, add this event to leftmost here, and so like at a type level, what leftmost is doing is it's just taking a list of events and combining it into one event. And why that matters is because if we go through this like this library, we'll see a lot of cases like for example, tag, which takes an event, right? So we still need to respect the type system. We can't say that tag, should take a list of events in some cases. That just doesn't. That's not something that will be scalable. And so we want it to always be that tag takes an argument of event um, and does something with it. So that's where leftmost comes in. And
If I might, and I know we got like 5 minutes left. I just want to add. I think the reason where I find leftmost is important is because it allows us to explicitly and declaratively define the order in which events should be considered. So like if you've
yes,
got like in this case, you've got 3 button clicks and you're like, well, I don't have 3 mouse cursors, so I can't really click on 3 buttons at the same time. But like, what if one of those events was, coming from a stream of input, right? Um, and you want to make sure that when you click on a button, that takes prior on the timeline, that takes priority over the next update from the stream, right? So maybe we got this input streaming from some server, but when we click, we want it to stop like right away.
yeah,
um, we can explicitly define that the click button event should take priority over the stream event. Um, and that's kind of what this leftmost is doing, is it's allowing us to organize the order in which the events are considered. And I believe it only takes one each render, right? Like it's only going to take the leftmost value. It's not going to do both of them. And so that's important, right? Because if you want to end an event as soon as a button's clicked, you might get race conditions in other languages, but this ensures that you won't. So, but yeah, continuing. Just wanted to
okay.
point that out.
No, that's a great point, and it's very much what you were saying before, with time. Like it's that's like leftmost is the first case where it's like that the idea of time actually matters, because it's like, what if all of these occur at the exact same time, um, and like there's more. Everything we're showing here is like what you need to get going with Reflex, right? Like we're not doing anything too complicated. Um, might feel complicated because it's new, but like it's hopefully not going to be complicated. Um, but there's a lot more lot more deep we can go in terms of how we define our applications and logic. Um, but for the most part, we can get away with like leftmost, for example. So, but yeah, no. So like how I was saying, if all three of these buttons fired at the same time, the value we would see is newer over value two, value three. For Haskell logic, just in terms of application, applying logic, we would see that newer takes the cake. So now I can just go absolutely nuts as a user. There's nothing that I can do which will break these. No sequence of events which will break these. And like the fact that like no sequence of events which can break this um, is really ultimately like defined or you know because of FRP um, and dealing with that event stream logic. Um,
Yep, we don't allow this library just doesn't allow the users control over those aspects of the program. You use dynamic, you use behavior, and you use event, and all you do is explain what should happen, not how it happens, and
sorry,
that's extremely important.
totally. So I am going to go a bit over time because there's still more I want to get to. Not too much longer, but I'll be quick with it. Um, the other thing we need to think about is like, so what if um, what if I want to do something um, with the current value of my text. So I am displaying it or whatever. But what if I want to do something with a dynamic? Is the key idea. So I'm going to take this dynamic and I'm going to print it. Sorry, console.log it is what I'm going to do. So um, I'll use my pre-render here. Do blank. I'll do lift JSM, and I'll use void here. Void will just destroy whatever I return out of here. And I am going to do this with, I'm going to have another function, log, and this is going to say log event. And I have another function here that I'm going to want to use, which is perform event. And you know what? I might not do this example because I will do this example. I'll explain this in a second here. Yeah. Okay. So what I've set up here, if you don't understand this part, that's not as important. More of the focus will be on the next part. But ultimately, what I'm doing is I'm using pre-render so that I can do some JavaScript here. And then we have this perform event function, which I'll show really quickly. And this just takes an event t performable a, and is going to return this as an event. I think I'm actually I want to use this because I don't care about the result back out of this this function here because I'm just doing console.log. I could in theory do this to like have a some JavaScript logic which is going to return back some information. Like for example, if I'm doing something with like a JavaScript API, like a like WebRTC, I might want to do that. This performable is another example of a type family. So it's gonna become some sort of monad for me, based on whatever case I am writing it, whatever context I am writing it in. But I don't need to think about that or even care about that. I guess it's just good to know. And let's see. There we go. Okay. So in my perform event, I'm just doing some lift.js, or I'm using lift.jsm. Lift.jsm is like the same thing as like what I was talking about with like the type families. Is like I just don't care about the context. This takes a lift.jsm. I should show it really quickly because I think this is a very concrete example of like ultimately like as Haskellers, we don't want to care so much about the context. We want to write context which will do stuff for us and then forget it exists. So this just takes something that will be of the type JSM and allows us to run it in any sort of generic context as long as that context has some specification. But anyways, the key thing here is now we are going to log whatever we have in our click here, or whenever we click on this. So that'll just be undefined. Actually, what is the type of this? Yeah, okay, interesting. I would have thought it would just print out the unit. But that's not very interesting. So what I want to do is I want to log whatever the text is right now. So I don't want to use, I don't need to care about this. I don't need to care about how it's displaying it. I want to care about what the actual value is, of course. And the way I can do that is by using the tag function. So let's say tagged equals tag of current value of my text. And I might have the ordering wrong. Forget which one it is. Oh, no, that's correct. So tagged is now going to be of the type event t text. And so, you know, what this is doing is the idea of sampling. So whenever this event fires, it's going to sample the value of my text. And when it does that sampling, it's going to grab a concrete value of my text. So, you know, for example, like a behavior, like a behavior of let's say like text is so similar to like just a raw text. It's not changing. It's immutable at that point, even in the context of JavaScript. And so there's a lot of functions you'll see which require you to give it something that is a behavior and not a dynamic. And so that's really easy. All you have to do is use current, which we'll see here. It just simply it extracts the behavior of a dynamic. Well, I won't explain. If you don't understand that, that's because I haven't explained why that is. But ultimately, it's just getting a copy of whatever that value is and turning into a dynamic. into a behavior, and that allows us, with the result of behavior, we can now use tag, which we'll see takes a behavior, right? So tag is the reason we need current, in order to get, because we're getting that behavior. And then what does that do? It, based on our type signature, even if we like don't read this, we can see that it's replacing an A with a B. So whatever the type of event is, it's just getting thrown, like whatever type is contained in that event is getting tossed out, and being replaced with whatever that behavior was. And that means that we have this event TB. So, right, we started with a dynamic text, we turned it into a behavior text, and now we have an event text. And so, now that we have that, we have written this logic that says, whenever this event happens, do whatever is here. So in the case of our function here, I've said that it should console.log the value of, I'm going to call this tagged prime, just to make that obvious. It's going to console.log whatever the value of that is. So instead of printing out undefined a bunch of times, this will now say, oh, what the heck am I doing here? I have done something wrong. I don't know what I did. I don't know why that's happening, but okay. You know what? I'm not sure why that's happening, but what I was expecting to happen, I must have done something weird. Really? Oh, because I am still listening to the logged event, not the value, we get from that log event, which is tag. So now, I believe this should work. There we go. So I can see I'm printing out the value of starter. So if I change this, now I see it's value 3. It's just up, whatever the value of this is, it's just going to console.log it. And so like, you can already see that like, as we continue to add logic to our application, it's not so difficult to think about it, or to continue adding on to the application. So the last thing I wanted to go over, I know we're going past time. I think it's worth it in this case. I totally understand if anyone needs to drop off. It will be on YouTube, and I can always go over this as well next week, or again next week. But the one thing we definitely should talk about is how to do XHR requests. Okay. There we are. So the first thing I want to say is like, especially if you do need to drop off, that there is like a little bit of a tutorial here in the module itself. And it shows us how we want to do this. I'm going to keep it very simple, and I'm going to say we're going to use this perform request async, And what we'll see, there's a lot of the bulk of the type signature is here, but again, we want to read this part first. Oh, pardon me. And what we're seeing is that we get an event T and return an or event T XHR request, and then we based on the type signature perform some action which results in a XHR response. So what is the value of my XHR request? How am I going to do this? I always kind of look back at this this tutorial here. Okay, so what's a good example here? I guess we'll keep it simple here. I'll just make an XHR request. I'll just build this thing. So wait. Yeah. Okay. So the easiest way to do this is just like get we haven't actually wrote any backend yet, but in the previous I think week 4, Kyle did have a backend. So we'll go in and request my data, and we see we have this default def is from the default package, and so that means that there's a version of, well, okay, sorry, based on this, XHR request is taking 3 arguments. First, the method, then the URL, which we've given it, right, get and my data, and then XHR request config, which is the bulk of what we need to think about. So, for example, we can add headers, a user, password, response type, send data, we can send some data with it, etc., etc. And we can even give some config about how the response should be. So I'm just going to say default for now, and then we'll say perform request async. Oh, right, because we don't have, so the error that I'm getting here is because it's saying that what I'm saying does not make sense. Why it doesn't make sense is that the request, the details of the request also need like the concept of like when the request should happen. So in order to do that, I'm going to say that this request should happen whenever log event happens. Okay, and that type checks. This is going to fail because I don't have anything set up there. Is it? Yeah, so we're trying to get my data. But it's not really showing anything back. We can pattern match on the response. And we could say, we have another thing, which is just whenever we get this response back, we are going to console.log it. Does that work? Oh, yeah. And we can't, there's no way to turn a XHR response into a JS file like we were looking at before. So if I look at, what can I print out here to show what's going on? Oh yeah, XHR response status. So let's this. Does that work? I might need to fmap it. Oh, right. There we go. So now whenever I press log, I am doing an XHR request, and the status of it is 200. So we didn't actually get any data back from it. I guess we could easily do that. Let's see this. I'm not sure if this will work right out of the box. Fair. Yeah, that's not going to work right out of the box because, well, because it's not just not a way to turn it into a JS file. I could, however, use like these functions here to decode the type of the XHR response and then do more with that. But I'll save that for a. What the heck did I just do? What the? Okay, I don't know what just happened there, but I just deleted everything. You know what? That's an embarrassing way to end, but I don't know what I just did there.
You're not making Emacs look that great.
What I did. Whatever. I think that's a good way for me to end. Besides that part, so there's more to cover with Obelisk. Everything we've done today is Reflex, and we'll get into Obelisk maybe next week or another time. But there is Kyle's example in I think week 4 that is more well-rounded for Obelisk. So with that said, is there any questions that anyone has?
Yeah, and all the code is on GitHub. I don't know if we probably need to make that link more accessible.
Yes, we definitely do. Yeah, we'll start sharing that link each time. Like, here's the link to the code. And put it in the description.
Nice if we had the code for this one, but Galen had to go and delete it.
I could rewrite it. That is insane. I'm trying to gatekeep the code, I guess.
Anyways, yeah, we went a little bit over, but thank you for everyone who stuck around. And yeah, please keep going on the projects. That is the only way that we can vouch for you as programmers. We just had a meeting with Nick, and so Nick's now got his first 2 projects have been reviewed, marked. He's ready to move on. But like we actually have data now for Nick, right? So like we need to build up data for all of you so that we can get you jobs. So this is really the most important part of all of this is doing those projects, and then not only doing them but explaining your thinking behind them, right? So for those, we will get on a call. We're doing those calls after the second. So once you've done project 1 and 2, we're going to jump on a call with you. That'll be, you'll have to talk, you'll have to use your voice for those meetings, because that's another important thing for getting a job, is being able to speak clearly. And then after that, after project 4, we'll also be having a meeting with you. So yeah, looking forward to seeing what you guys come up with, and best of luck. And we're here to help along the way. Like if you run into a problem, you can't move forward, don't go more than a couple of hours being stuck. Just reach out.
Ultimately, we want to see you guys succeed. And I think even too, like one thing I'm realizing, like with this program, is like it's far more about like making you guys into excellent communicators, because like than it is
Yeah.
about like writing like the most beautiful perfect code. Um, obviously there's a lot of people in Haskell who are like obsessive about like the code they write, myself being one of them. Um, but like the key thing that's going to help you guys with getting a job is the communication. And so why we're teaching Haskell in terms of communication is because I think it's so much easier to explain your logic once you've gone through something like Haskell. It really brings down by an order of magnitude the ways in which you need to think about a problem, and makes you and because you can think in that much more refined and simplified manner. Um, it's a lot easier to explain what you're thinking when you get into these technical interviews where they're going to ask you about architecture, and etc. So yeah.
Yeah, and on that, like Lauren's going to do a lot more of the interview prep stuff, but I will just add to that, like you can be the best programmer in the world if you can't if you basically it's like it's really harsh out there in interviews. If you show any sense of um, like literally just saying the word no can have you be not, or like I don't know, or like these words will literally just like kill the interview for you. Like you really need to be able to, like, even if you don't know something, like the tricky part about it is even if you don't know the answer but you really want the job, you need to be able to come up with like how you would approach the problem, right? Rather than saying, oh, I've never done that, you say, this is how I would approach it. This is how I would find out the information. And this is, I know this will work because of X. I know that if I do this, you know, you can get into first principles thinking and all of this stuff, which is literally what we're teaching you here. Like, there's really no way to succeed in Haskell without doing first principles analysis. Like, you need to be able to look at the types, figure out how to fit all of these things together. You can't just look up a library and throw it into your code and hope for the best. Like you need to know the types of the functions that you're using and how they interact. So yes, Haskell's a fantastic language, but there's a reason beyond just learning Haskell. Like there's a reason that we're teaching it to you, and it's beyond just being good with Haskell. Ultimately, if we can find you Haskell jobs, that's a bonus for everyone because they pay really well and it's fun. But like beyond that, this is teaching you how to think through programs and probably be the voice on the team that's like, hey, why are we having bugs at runtime? Let's fix that. Let's change the way that we work. It's very much like that. And communication is going to be your most important thing. Like hands down, you need to be able to communicate. And so, typing in the chat is great, but we really do encourage you to like try to use your voice just because it's going to help you practice. And obviously, right now you're just learning, but I think when we get onto those calls where we're walking through, I think those are really good opportunities for you guys to basically practice being in an interview because we're going to be asking you questions similar to what an interview would be asking you, but just you should be perfect. You should be great at it because you wrote the code. So you'll be able to explain to us how that works. So yeah, without talking too much more, that's just a little bit of motivation for getting these projects done.
Yeah. Yeah, and like we ultimately want to to build you guys into like people who in the interview are like super confident with good reason.
Yeah.
Because I think like in these technical interviews, false confidence doesn't get you too far.
No.
So
It
we want.
can if you trick them, but
Yeah,
you don't want to be tricking them.
it
You want to
can.
have true confidence.
I am oversimplifying. It can get you far, but like also, even that said, like what definitely will not get you far is like not having confidence in yourself. And so like
Yeah.
again, that's why we do Haskell here because like we want it to be that you guys like can can look at your own skills and say like okay, like I know what I'm talking about. Like I understand I understand logic, I understand applications, um, and I understand what a good application is and what a bad application is. So yeah.
Yeah.